Hi, my name is Tom. This is a presentation of my information retrieval semester project focused on classifying U.S. Supreme Court legal opinions. We're going to talk through three areas in this presentation: the problem of motivation, the approach, and then the results that observed in this project. So we'll start off with the problem and motivation. Primary motivation is to automatically classify the legal opinions out of the Supreme Court. Wanted to grab pretty much everything that we could get our hands on and see if we could infer anything from the data contained therein. And then secondarily, just kind of as a little icing on the cake, if you will, given the contemporary situation with the Supreme Court Justice Scalia, who passed away, wanted to see which president had actually appointed the Supreme Court Justice who actually read the opinion, and then present that. And that was not so much a text classification problem as just a kind of a lookup table. So let's move on to the actual approach for the main body of the project. So the approach included these four main areas, and it's probably appropriate time to present the kind of the key for looking at these notes here. The stuff in the purple, this is kind of a bash shell script, or rather indicates I had to use a bash shell script to facilitate some of the processing. And the stuff in the green means I wrote a little Java program to help out with it. And of course, this is kind of a wrapper here for this SVM, the bash shells to actually launch the SVM binary. So let's go up here and start with the data prep process. Both our text and then a number of the other projects that are aligned with text classification, I talk about the importance of ground truth. So we looked at, so this is the ground truth for the information. So I'm not a lawyer. I had to look up a lot of this information so I could learn how to read this. And there's some Supreme Court specifics. There's majority opinions and dissenting opinions. And actually the best thing I found was this PDF from the American Bar Association. And it's actually focused on how do you read a Supreme Court opinion. And it's actually presented right here. And it goes through the various parts. And this was invaluable to me as I began to look at building the logic out to make this all come together. So essentially things are broken into the syllabus, which describes some general information about the legal opinion. Let's see if we've got any more here. The big thing I was looking for was what was the case title. So when I was doing the initial investigation, I used like find and grep a lot. So this is just some of my notes on that piece of it. And then there's the main opinion, which is the actual meat of what we were looking at. And we're looking for both who delivered the opinion and whether it was opinion of the unanimous court. And we'll get into a little bit more later here. And there's some other nuances we didn't actually include in the scope of this project. There's the main opinion, but in the case where the court was not unanimous, there can also be dissenting opinions, or you could have a unanimous court, but you have some justices who said, well, I used a different rationale. So I did some initial looks at doing that, but we focused more on just the syllabus and main opinion. So after doing some investigation, I kind of decided to look at doing 5 binary classes. and these are the actual features that I use to identify those binary classes. So we've got the unanimous class, the affirm class, the reverse class, the remand class, and then the reverse and remand class. And you see the various feature vectors that I was able to infer in the sampling of data I was looking at as I was beginning to build this out. Excuse me. Okay, so next question is, I'm in the subject here of data prep. Well, so where the heck did I get this information? Well, I got this actually from the U.S. Supreme Court website. They publish all of this information in PDF, and they have just about, they've got 2003 to 2015 listed on their website currently. So what I did was, again, leveraging the fact that we've got this indicator of purple being indicative of like a bash script that I wrote and wrapped around other stuff. I codified some logic in a bash script to make a wget request to go grab the information from the U.S. Supreme Court website. After I had everything staged, you pull everything down in PDF, and you can kind of see that here. This is my request in to pull down in PDF format. You need to convert that information from PDF to text to facilitate the text processing. And thankfully, there's an Apache project called Tika, which also was used in the Panama Papers recently, and it's really handy for being able to convert the PDFs into text, so we can then do the additional processing. Then I had just another little thing here. There's some duplicates. The stewards behind the U.S. Supreme Court, there's just a few things that could be improved. There's not things are not particularly standardized, so I had to do some cleanup there. So the next piece, since we're leveraging machine learning and specifically SVM Lite, we've got this data, but we need to break it up into the training portion, the development portion, and the test portion. And there's about 996 opinion files there, and breaking that up into a random fashion. That was going to be difficult to do by hand, and I was lazy, so I looked at automation to facilitate that, and I found the GShuff utility, which I was able to install on my machine. I'm running a MacBook Pro, and it was just an additional utility I had to install with Homebrew, but it was neat, and it allowed me to establish a enumeration here. As you can see here, this is the actual command that I wrapped in the bash shell, and allow me to break these things out. So after I would run it, I was able to take that main set of converted data and put it 70% into train, 15% into dev, and 15% into test. Okay, moving out of the data prep process and into the bulk of this. I won't go over everything. This is largely my algorithm I used for processing the information. Employed hash maps heavily, but for each text file in the directory, I was doing checks to see if each line contained like the case name or the author, and then also beginning to catch some of the edge conditions like opinion of the court instead of when a judge was actually presiding, and then just kind of going on with the processing of this and putting it in the appropriate file so that I could then run the SVM after this. Somewhat similar to what we did in I believe it was program 4. When I call out this one item here, I have bolded. Since I was putting this together, I had the source files, but I didn't have any definitive classification from like a lawyer per se against my 5 binary classifiers. I had to get a little bit creative, and what I did, I said, hey, if I'm doing like a training or a dev operation, because again I ran across train, dev, and test. Train and dev, I needed to mark each row, and I said, look, if we've got any of the feature vectors have matched, we're going to go ahead and mark that row as being a member of the class instead of not being a member of the class. And this is a little bit black and white. Of course, I didn't sample everything. It seemed to work okay across the samples I looked in. But I may not have grabbed everything that, say, a lawyer or a legal aid would have captured. Okay, and again, this was the bulk of the actual coding. Had to parse the feature file here, each of the classes, and build everything that we'd be looking for, maintain that information in the hash map. Moving on to the next set, where actually applied the machine learning. We trained, validated, and then tested against each of these 5 different classes, and I had a model for each class. And again, leveraging the purple background here, that means I wrote a bash shell script around the actual SVM commands to facilitate processing this information and putting it all in the appropriate place in the file system. To end, I wrote another little program called the summary processor. We've got the summary information, but it was difficult, I found, to look across 5 separate files of predictions and just looking at the ones and minus ones, or greater than that, depending on the weights of the classifier that were applied. So I wrote another summarizer processor routine to look across some of the summary output, and then to look across all 5 of the predictions and summarize that in a more user-friendly way to say, hey, were we successful or not? And that also facilitated the overall results. And we'll go through the stuff here at the very end. So for the overall results, had about 90 of the 150 in the test set had at least one classification. And if I had to do it again, I think more classifiers, or rather more features per classifier, would have been better. And it would have been probably more, would have got better results if we had either like Mechanical Turk through Amazon to grab legal expertise, or pay legal aids to classify some of the opinions, instead of just doing the rather abrupt decision to say, hey, if you had any members in that that matched that feature, we're going to go ahead and mark you as being a member of that class. Let me quickly go over to show you a sample of what the PDF looks like when you pull it down from the Supreme Court. So this is one from 2004, and they range from I think this one's about 23. I think the most I saw was in the neighborhood of 60 or 70 pages. So they're down in a PDF form, and then you use that little TK application to convert it over to text. So for this last screen that we've got over here, this is actually the view from the IDE. Kind of facilitates a consolidated view. That same PDF that we just saw, here's the text version of that, and this text version is what we processed across to everything. Here's what the feature file looks like when it's read in. So we've got the class, and then we've got each of the features with the term ID across those. So unanimous, affirm, reverse, remand, and reverse and remand. Here's a judge appointer list, which shows across those justices that have served the period 2003 to 2015, the judge's name and then the appointer and their political party. We'll quickly go through this. This is the we're just looking at the affirm classifier. This is the output data after we've done created the training data, and we see here, we see this is valid, and we've got 40 with 2. We go back here and we look at affirm. We look at term ID 40, so we affirm occurred twice. Similarly here, this is off the dev set. 40 means we saw it the we affirm once. And then here we have the actual test set. You notice we have 0 of these things have not been classified yet. This is what we use the SVM to do the processing. So I did the SVM processing and then wrote the summary results over here. And you see here that we've got a listing of all of the 150 documents that were in, opinions that were in the test set. We had 90 of those that had at least one classification. Some had more, like remand and reverse. Going back to the top, the title of the case, the judge who read it, the president who appointed them, their political party, the word count of that particular opinion, and then the appropriate classification. Well, thank you all for joining. This has been an overview of my information retrieval semester project, classifying U.S. Supreme Court legal opinions. If anybody's interested in the code, I do have this up on GitHub in a private repository. Just email me your GitHub handle, and happy to share the information with you. Thanks.